What if you could build a production-ready, WebAssembly-powered custom policy for MuleSoft Omni Gateway in Rust with an AI developer agent guiding you through every step? That's exactly what we're going to do in today's video. I'll show you how I used MuleSoft Vibes inside Anypoint Code Builder to create an IP Allowlist policy from scratch, compile it into WebAssembly, publish it to Anypoint Exchange, and apply it to an API managed by Omni Gateway. And the best part? You don't need any previous Rust experience. Let's build it. Before scaffolding the custom policy, I asked MuleSoft Vibes, can you verify that all the prerequisites are installed and configured on my machine? First, it checked Anypoint CLI version 4 and confirmed that the PDK plugin is installed. Next, it verified the Rust toolchain and confirmed that the required minimum version is available. It then checked the WebAssembly compilation target required to build the policy. After that, it verified cargo-anypoint, the PDK extension used to build, package, and test MuleSoft custom policies. Finally, Vibes confirmed that the Anypoint Platform credentials were correctly configured in the CLI by listing environments. Everything is green, and we're ready to start building our custom policy for Omni Gateway. Instead of manually creating the project structure and configuration files, I gave Vibes a single prompt. Create a new Omni Gateway custom policy project called IP Allowlist Policy. Vibes understood the requirement, loaded the develop PDK policy skill, and executed the policy development kit scaffolding process. And within minutes, I had a complete and compilable Rust custom policy project for Omni Gateway. Let's review some of the important files generated by the scaffolding process. First, we have cargo.toml file, which is the Rust package manifest. It defines the project metadata, required dependencies, library configuration, and build settings. Next, we have the Makefile. It provides a clean set of lifecycle commands for building, testing, packaging, and publishing the custom policy. MuleSoft Vibes will use these commands throughout the demonstration as we take the policy from source code to enforcement on Omni Gateway. Next, let's look at the gcl.yaml file. This file defines the configuration contract between our custom policy and API manager. In simple terms, it controls how operators configure the policy when applying it to an API instance. Let's break down the important sections. First, kind::extension. This identifies the asset as a custom policy extension created using the MuleSoft policy development kit. Next, the interface scope is configured for both API and resource levels. This means operators can apply the policy across the entire API or target specific resources and methods. Under Properties section, the allowed IPs property is defined as an array of strings. This allows operators to configure multiple entries, including exact IP addresses and CIDR ranges. The rejection message property includes a default value. That message is automatically pre-filled in API Manager, but operators can override it when applying the policy. Both properties are marked as required, so API Manager validates them before allowing the policy configuration to be saved. Whenever we modify gcl.yaml file, we run make build asset files command. The PDK then processes the updated schema and automatically generates the corresponding strongly typed Rust configuration structure in config.rs file. This is entirely generated code, so we should never modify this file manually. When Omni Gateway initializes the custom policy, the PDK deserializes the configuration supplied through API Manager and injects this generated structure into the policy's entry point. Now let's look at the main implementation file called lib.rs. This is where the actual request processing logic for our Omni Gateway custom policy lives. First, PDK-HL imports the high-level policy development kit APIs used to interact with the request and control the policy execution flow. Next, IpFilter imports MuleSoft PDK's built-in IP matching engine. It allows the policy to evaluate client IP addresses against both exact IP entries and CIDR ranges configured in API Manager. Then, Logger provides structured logging from inside the WebAssembly policy runtime. We'll use it to record important events such as missing headers, allowed requests, and blocked IP addresses. Finally, we import config, the strongly typed configuration structure automatically generated from our gcl.yaml schema. With these imports in place, we can now initialize the policy and implement the IP Allowlist validation logic. Next, let's examine the function marked with the hash entry point attribute. This function initializes the custom policy when Omni Gateway loads the WebAssembly module. it performs four main operations. First, it deserializes the policy configuration received from API Manager into our strongly typed config structure. Second, it creates an IP filter using the configured allowed IPs entries. Third, it registers a request underscore filter closure. Although the entry point initialization happens once for the loaded policy instance, this request filter is executed for every inbound request processed by that instance. Finally, it launches the PDK processing loop, allowing the policy to intercept and evaluate incoming traffic. The request underscore filter logic is clean and easy to follow. It handles three possible outcomes using a Rust match expression. Case 1. The X forwarded for header is present, and the client IP matches an entry in the configured allow list. The policy executes and Omni Gateway continues processing the request and forwards it to the upstream API. Case 2. The header is present, but the client IP does not match an allowed IP address or CIDR range. This breaks the flow and immediately stops request processing at Omni Gateway. The upstream API is never invoked, and the client receives an HTTP 403 forbidden response containing the configured rejection message. Case 3. The X forwarded for header is missing. The policy breaks the flow, follows a fail-close security model, and returns the same HTTP 403 response. One important security point. This approach is safe only when the trusted load balancer or reverse proxy overwrites or sanitizes the incoming X forwarded for header. Otherwise, a client could supply a forged header. In production, we must establish a trusted proxy boundary before using this header for access control decisions. Now let's bring it all together. 3 commands. Now, let's look at what happens behind the scenes when we run the make build command. First, it runs build asset files, which reads the policy contract from gcl.yaml file and regenerates the strongly typed Rust configuration in config.rs file. Second, it executes cargo build command with target and release parameters. This compiles the Rust implementation into the optimized binary that Omni Gateway will load and execute. The final step is publishing our custom policy to Anypoint Exchange so that it becomes available in API Manager and can be applied to APIs managed by Omni Gateway. First, we have the development publish command make publish. This is designed for rapid iteration and team testing. The publish target adds a dev suffix to the asset ID and generates a timestamped version. This allows us to publish multiple development builds without overwriting the production-ready policy asset. It is ideal for validating changes, collecting feedback, and testing different policy versions before creating an official release. Once testing is complete, we can publish the production release using make release command. The release target publishes the policy with its official asset ID, IP Allowlist Policy, and a clean semantic version such as 1.00. This is the production-ready policy asset that platform teams can discover and use through API Manager. Now, let's sign into Anypoint Platform and verify the 2 custom policy assets we published to Anypoint Exchange. Here they are. Both the development and release versions have been published successfully and are ready to be applied to APIs managed by Omni Gateway. Now, let's navigate to API Manager and apply our custom IP Allowlist Policy to the agent broker endpoint managed by Omni Gateway. In the policy configuration, I'll add my laptop's current public IP address to the allowed IPs list and save the changes. Next, let's open Postman and send a request to the broker endpoint. The request is successfully allowed by Omni Gateway, forwarded to the broker, and we receive an HTTP 200 OK response. This confirms that the custom policy is active and correctly permits requests originating from an allowlisted IP address. Now, let's update the policy configuration with a different IP address, one that does not match my laptop's current IP, and repeat the same test. I'll return to Postman and send another request to the agent broker endpoint. This time, Omni Gateway blocks the request and returns an HTTP 403 forbidden response with our configured rejection message. The request is rejected directly at the gateway and never reaches the upstream agent broker. This confirms that our custom IP Allowlist policy is working exactly as expected. Requests from allowlisted IP addresses are permitted, while all other requests are blocked. And that concludes our end-to-end demonstration of building, testing, publishing, and applying a Rust and WebAssembly-powered custom policy for MuleSoft Omni Gateway using MuleSoft Vibes. If you found this video helpful, please subscribe to MuleAce Academy and share it with your MuleSoft community. Stay tuned for more practical content on MuleSoft, integration architecture, and agentic AI.